The topic which we are going to cover today is, first of all, we'll have a recap of lists, and after that, we'll have a recap of uh, both the array list, linked list. Okay, and after that, the next topic which we are going to cover is the second part of collections, that is sets. In sets, we have hash set, tree set, and linked set. That is what we discussed yesterday. Okay, so we'll be covering these three topics. And in list also, I'll cover one more scenario where I'll show you that how insertion at the start in array list take more time as compared to linked list. Then at the end, like once this list and the sets are done, then we'll also cover up maps. In maps, we have hash map, linked map, and tree map. So I'll be covering all the three. And then we'll go back to Selenium. Okay, so let me create a package for today. Let's name it day 13. Okay, so first of all, I'll create a class and uh, let's cover the list example. List time example. I'll keep this public static void main chat. Okay, now before I see this, let's have a recap of whatever we studied in the last class. So first of all, we started with the problem which we face with arrays. The problem which we face with array is that the size of the array we mentioned in the start, and that is fixed. You cannot change it at runtime. And if let's say number of data is coming more, then you have to create another array of double the size and then copy paste the value and proceed. Right. So there is always a challenge of updating the size of the array. Therefore, they come up with one solution where the size of the array is not necessary. So that comes under one class called collections. Collections is something which is there in Java. In that we have something known as list. List is an interface which is implemented by uh, two I mean subparts of list. One is array list and second is linked list. Okay, so array list is has the implementation of array list. We discussed that it uh, internally it creates one array of some size. Let's say I have and the default size which it creates for the first time, we saw that it was 10. So it creates an array of size 10, and after that it starts filling in values. As soon as those 10 values are filled, that array gets filled completely. Then the 11th element which we have to insert, for that a new array of double the size is created, and that 11th value is put in that new array. Okay, and again it will work like this, and everything of this happens at the back end, so you don't have to worry about. So here you can see, to add values to an array list, we have a method called add. Then the way we define the array list is like this. Array list is the class. Here you are mentioning the data type. So here we pass, instead of primitive data type, we pass non-primitive. That is, there is a class called integer which has implementation, some methods like converting a string into an integer and so on. So it's a wrapper written over primitive integer. Then I just created it and initialized. So here you can see nowhere we are giving the size. Then to add the values, we have dot add method. Dot add method is a overloaded method. We have two ways. One where we are just passing the value, and second where we are giving the index and the value. Okay, like here you can see I'm giving the index of the array and its value as well. So at second index I am inserting 78 value. Similarly, so these are two different methods to add the value. Then we saw how to get. So to get the value, the method is dot get. Okay. Then we discussed about the linked list. So in linked list, methods and everything's remain same. So code wise, there is no difference whether you're working on arrays or linked list. Difference is in its implementation. So we saw that in case of linked list, different nodes are created. Each node has two things. One, the uh, address of next memory location, and second, the value which we want to store. Okay, So that is what we studied in linked list. Rest everything will remain same. And then we also discussed about the iteration over a array list or linked list, that is with enhanced for loop. So here uh, we are using the simple enhanced for loop. Here for loop, for is the keyword, then you mentioned the data type, then a temporary variable, and colon the name of the list or collection over which we need to iterate. So in temp, one by one values from linked list will come into the this variable temp. Say for example, this linked list has some 12 values. So first time linked list of, I mean, the first value will come, then second, and so on. So we have not seen this in debug mode. Let's look at this iteration in debug mode. So I'll just execute, right click, debug as Java application. So here you can see one of the variable is created with name linked list. If I open it, it has two values, first and last. First is basically the one which has the first value, that is the top I was telling you yesterday. So it stores the address of first memory location. So if you open it, you can see that it has many things: item, next, previous. So the linked list implementation in Java is like a doubly list. That means it stores the address of next as well as the previous one. Okay, so here you can see the value in it is 45. So the first memory location has a value 45, and then it also has it is also storing the next address. So next is, you can see that item is this and value in it is 49. Then in this the next is given. So here the next is which has a value 89 and so on. So the way we discussed yesterday, in debug mode it shows like this. So the first we have a memory location, first we have a node. Okay, then it has address of next one. So there is next node. So it stores the address of next node, then it stores the address of next node. The only thing is, in Java, this linked list also stores the address of the previous one. So this stores not only the address of the next one, but it also stores the address of the previous one. So this is known as doubly linked list. Okay, you don't have to worry about this because all these things internally take care. Okay, similarly here, it also stores the address of next one. Also, it stores the address of the previous one. Okay, so it is doubly linked list like this. So any questions till now? Okay, now let's look at how the values are assigned. So if I run it in debug mode, so here you can see we have this linked list created. Then when I execute this statement, you will see a temp variable is created. So here a temp variable is created, and if you look at the value of this temp variable, it has the value from the first location 45. So that will get print. Then in the next, so here you can see 45 in the last 45 might have printed. Yeah, 45 got printed. And after that, if I execute it again, this time the value of temp, if you look at the value of temp, this is 49. Okay, so like this, keep on iterating and its value will keep on changing. So values from linked list one by one are coming to temp, and that is what we are using. So that's how enhanced for loop works. Okay, so yeah, that's all in linked list. Now I'll come back. Any questions, anyone? Okay, then let's start with the time consumption. So as I said that array list, when we insert value at the start, takes more time. So let's see that actually it is true or not. So here I'll create one variable called array list. Let's say the data type is integer, and let's say the name is array list. Okay, equal to new array list. Okay. Now I want to insert the values at the end. Okay. To count the time, I'll write small logic, and the logic will be I'll create one variable long and I'll name it start equal to new is equals to system dot current time in milliseconds. Okay. So what I'm doing, I'm just taking the start time before starting insertion. Okay. Then here I'll start with a for loop for int I equal to 0, then int I equal to 0, then I less than 10 e5. What does this mean? This means 10 raised to power 5. Then I plus plus, and here what I'll do, array list dot add. At the end I have to insert the value, so I'll just insert I in it. I mean every time whatever is the value of I, that will get inserted in it. And then I'll create another variable, we'll name it end, and here we'll simply say system.out.println time taken in uh, insertion at start. This will be end minus start milliseconds. Okay, so time taken in insertion, end minus start. So whatever time will be here and whatever is the time before start. So the difference between it will be something which will be taken by this. Okay, so this is one. Then same thing, will create another array. We'll create another array list. Let's say I name it array list 2. Okay, and here let's say I'll just remove this long because start variable is already there. I'll remove this end, and time taken insertion at end. This time we'll say time taken insertion at the end will be end minus start. Okay, this is end and the other one is start. My bad. So to make it start, what we have to do is change this value to 0. I mean here it will be 0 comma I. So at every time at 0th location we are inserting one value, and that value can be anything, whatever is the value of I, that will start getting inserted in it. Okay, so for when it run for the first iteration, it will insert 0 at 0th location. When it will run for second time, it will insert 1 in 0 location, then 2 at 0 location, 3 at 0 location, 4 at 0 location, and so on. So this is how it works. Now here also I'll change it to 2. Yeah, so if I execute it now, let's see how what time it takes. So you can see the insertion at the end has taken only 73 milliseconds, whereas the insertion at the start is still executing because the number of iterations were 10 raised to power 5, so it is taking a lot time. Let's just wait for a couple of seconds. I guess it has become too much. I should have keep it 10 raised to power 4. So you can see that insertion same number of operations, like here also I'm inserting 10 raised to power 5 values. Here also I'm inserting 10 raised to power 5 values. This one is taking only 73 milliseconds, whereas the other one is still executing. It has taken almost, okay, let me do one thing. Let's change the value to 10 raised to power 4. Okay. So if I execute it again, so this time you can see that here the values are 10 raised to power 5. Here the values are 10 raised to power 4. That means 10 times less value, but still it is taking almost 50 times more value. Not 50, rather. more, even more value. 20 times more. Yeah, 20 times more, almost 20, 25 times more values it is taking. Okay, so this shows that insertion in the start is too much time consuming is if your data is high in case of array list. Okay, so same example now I'll do it with the same example now I'll do it with linked list. So I'll create another class, linked list example. I'll keep it now here. Here I'll change all array list to linked list. Okay, replace all. So yeah, so all array lists are changed to linked list. Here I'll just change it to right click, refactor, rename. Just change the first letter to small one. Okay, guys, just give me a second. I am getting a call. Okay, so I've changed it to linked list everywhere. Now everything else remains same. Here we are adding the value in the start, sorry, at the end, and here we are adding the value in the end. And let's keep the value as same. Here also I've taken 10 e raised to power 5 and here also same. So if I execute this code now, you can see that, let it execute. So you can see that it has taken almost same time. In fact, insertion at the start has taken less time, but that is very less differences there. So to insert 10 raised to power 5 values, that means a good amount of values we are inserting. Uh, in either the insertion at the end or insertion in the start, both of them has taken almost same value, or there is very less difference, only twice the difference. Whereas in the array list it was 20 time difference, even though the number of values were 10 times less. So this shows that the linked list insertion at the end or insertion in the start takes similar time, and that is very less as compared to array list. So that's the reason I said that when number of data is very high, it's always good to use linked list than array list, because array list, one thing, takes lot of time, and second thing, if data keep on increasing, that then the memory allocation will be very high in that case. So this is about uh, linked list and array list. Any questions in this? Okay, so I'll move on to the next one. Next is sets. So we have sets now. I'll be starting with sets example. I'll just name this, and we'll keep public static void main checked. Now what is a set? Set are of three types as I discussed, but what is a set? Set is something which stores unique unique value only.
Sorry, one question I have.
Yeah, yeah, Priyanka.
Yeah, when we done the same example for array list and then for the linked list, array list took less thing, maybe C.
Array
There
list.
is very minor difference. Yeah, array list took less time. It's around
Let me
500
execute.
seconds, I guess.
Let me execute. It took 54 milliseconds when the insertion was at the end. Okay, so
Mm-hmm.
if you remember yesterday we discussed that use array list when data size is small, or insertion or deletion at the last is more. So this thing I mentioned. Whereas when it comes to the insertion in the start, it is taking almost 1290 seconds, though the number of values are 10 times less. Here the number of values are 10 raised to power 5, whereas here the values are 10 raised to power 4. That means there is a difference of 10 times value. Then this difference is coming. Whereas in linked list, whether you insert, if I execute this, when you execute this, insertion at the end is taking 1300 milliseconds, but yeah, insertion at the start is almost half. So the difference is not there. So what my point was that if you have insertion and deletion in the start, more insertion and deletion in the start, then it is always advisable to use linked list. Even if you have insertion at the end, then also you can go through this because time difference is less. Okay, but but still, if we have to go with the insertion at the end, then array list is better. So that's why I mentioned these things in the in last class. That data size is small, then go with array list. Insertion or deletion at the start is more, then sorry, less at the start, then go with array list. Insertion deletion is more at the last, then go with array list. Here we have only 2 points. One, data size is large, then go with this, and second thing, insertion and deletion are operations are more anywhere, maybe insertion at the start or between or at the end, then go with this.
Okay.
Yeah. Okay, so moving ahead, next we started with sets. Sets, as I was just explaining, that sets are something which does not allow duplicate values. Okay, so here sets stores unique value only, does not allow duplicate values. Okay, there are three types of sets: hash set, linked set, and tree set. Uh, when I'm saying it does not allow you duplicate values, that means if you see any linked list or array list or a normal array, they have something known as index, and at any index you can store any value of that data type. Even you can have an array of size 10 which has all the same values. Let's say 20 is the value, and there can be an array which can have all the 20 values. Whereas in a set, you can have only unique values and it does not have any index. This is very important point. Your set does not have any index. It stores value. When you have to get, then I'll show you how to do that. So there are three types of sets. One is hash set. This is the basic one, most basic one. Again, you have to take one from java.utils. Here, give the data type. Let's say this time, let's say I take string. Uh, let's say I created a hash set equal to new hash set. Okay, now hash set dot, when you have to add value, there is no overloading of add method here. There is only one add, that is which takes this value. So here if I'll say add, then you can simply add a value. Let's say I add Monday. So if I add it again, okay, so I'll add, let's say, Tuesday, then Wednesday. Okay, and again I'm adding Monday. So if let's say now I if let's say now I print all these hash set. Okay, I'll just print like this, so you can see that it will give you values like this. See here, though I have added four values, here the values which are coming are only three: Monday, Wednesday, Tuesday. Okay, and if I add few more, let's say I add four more: Wednesday, Thursday, Friday, Saturday, and then Sunday. So I have added all the days of the week. Now if I execute this code, you can see that it is giving me value Monday, Thursday, Friday, Sunday, Wednesday, Tuesday, Saturday. See, Monday is coming only once, though I have added it twice. So in case of set, it consists of unique values only, and it stores those unique value once. They'll not store multiple times. Another point to remember that a hash set or any set does not have any index. Here, it does not have any index. They all are stored in some way, but yeah, no index. One more point, if you observe, in case of hash set, when I'm printing it, that means when I'm trying to get the value, that time the order in which you added is not stored. So you can add value in any way, and when you retrieve those value or when you get those value, that order can be anything. They will never be in the order the way you added. Okay, so there is no order, it is randomly you are getting. So this was I was just printing. Now if you want to get values one by one, then what is the way? You can use enhanced for loop. So for string, let's say I create a temp variable colon, then hash set. Okay, now here I'll simply print the value temp. When I execute it, you will see values are coming one by one: Monday, Thursday, Friday, Sunday, Wednesday, Tuesday, Saturday. There is no order. All the values are coming randomly. So this is what hash set is. Points to remember: hash set is something which allows only unique value, does not allow duplicate values. Uh, they don't have any order. The order in which you're adding may change, may vary. So if let's say one time you are applying a for loop, you may get some order. Next time you are applying the for loop, you may get some other order, or you may get same as well. So there is no order maintained in case of hash set, whereas uh, it only allows duplicate value. It won't allow any I mean similar value to be added twice. Clear? Any questions, anyone? Okay, then let's move on to the next one. So for next one, I'll just copy this set, paste it here, and we'll change it to, let's say, linked sets example. Okay, and here I'll just change hash set to linked set. Rest everything will remain same. Okay, what? Just a second, I guess I used control F, linked set, replace all. Okay, the name is linked hash set. Okay, and here also I'll change it to hash. Okay, so the name is not link set, it's linked hash set. And here I'll just refactor it, right click, rename, refactor, rename, and here I'll change it to linked set. Rest everything will remain same. So what is benefit of having linked list, linked set or linked hash set? Uh, See, in hash set we studied that they don't store any order. The value, the way in which you are adding the values and the way you are retrieving the values, the order is different. Okay, when you're getting a value from hash set, that can be any random order. Whereas in linked list, sorry, in linked hash set, the values in which you add the values will the order will be same. So the when you retrieve these values, the order in which you have added will be the same. The order of getting the values. So here you can see you added values Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So here also you're getting the same order Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay, and here also duplicate values are not there. So the order in which you are adding the value is the same order in which you get the value. That is uh, what happens in case of linked hash set. Clear? Any questions in this? Okay, then we have the last one, that is tree set. So tree set is, I'll copy it again. Let me paste it. Okay, so here I created tree set. Okay, in tree set, instead of linked hash set, we have tree set. You have to take one from java.utils. So same thing I'll put here. Okay, and here you need to rename it. Right click, refactor, rename. So here it will be any name you can give. So I'll just give the name tree set. Okay, so when you use tree set, what it do is it also stores the unique value, and it also stores the value in alphabetic order. So here you can see the order is like earlier it was Monday, Tuesday, Wednesday, the way we added, but this time when you're retrieving the value, the values are coming in alphabetic order, as F comes before M, then M comes before SA, SA comes before SU, TH, TU, WE. So it is alphabetic order in which you get, and the alphabetic order is ascending order. Okay, ascending order is the order in which you will get the values back. Clear? Any questions here? Okay. Now, one more point. In case of tree set, we discussed that the order in which you'll get the value is alphabetic order, and that to increasing order. But you can also change it to reverse order, and that is by collection, not collection, it is collections. Yeah. So this is something which you need to add, collections dot reverse order. What this will do, it will reverse the order in which you are getting the values. So earlier you were getting in ascending alphabetic order, now you are getting in descending alphabetic order. So this is about tree set. Okay. So now I guess you will get to know that what is the order in which you should get the values. So always remember, I mean, sorry, my point is now you know when to use which. So use hash set when no order is necessary, no order is required. Use tree set when you need alphabetic order, maybe increasing alphabetic order or decreasing alphabetic order. And third is use linked hash set when uh, when the order in which you are adding the value, same order you want to retrieve them back. So in that case you can use the third one, that is linked hash set. Clear? Any questions? Okay. Now why we discuss linked lists and sets, because in Selenium there are few things where we get some more than one data, and that data comes either in lists or comes in sets. So going forward, I'll discuss when we get values in lists and when we get values in sets. Okay. Third is hash map. Now we are going to cover maps. Uh, maps are something which are not used in Selenium. I mean, nowhere you will get values in Selenium, but sometimes writing certain utilities, uh, we come across a situation where we need something where we can store values in key value pair. Okay, so that's the reason this hash maps are, sorry, maps are famous. So now I'll explain you maps. We can discuss in basics of maps. Okay, so if we talk about maps, then again we have three things in map: hash map, linked map, and tree map. So let's talk about them one by one. So first of all, I'll discuss hash map example. Again, we'll keep this public static void main checked. So what is a hash map? Hash map is something which stores value in key value pair. Say for example, you all are working in an organization, so you all of you have your email ID, you all of you have your employee ID and then name, right? So employee ID is something which is always unique, so we call it a key, whereas name can be same. There can be two employees with same name Saurabh in an organization, but for both of them, employee ID will always be unique, right? So here also when we are creating a map, so I'll create a hash map. Again, you have to take one from java.util. Here you give key and value. Now again, this key can be of any data type, value can be of any data type. Say for example, I'm putting both of them as string. You can put both of them as string, or you can put this one as integer and the other one as string, or any data type. You can have any data type here. Let's say hash map equal to new hash map. Okay, so this is how you will create a hash map. Now again, you can see there is no size defined in it. Okay, and when you put values in it, it will be like hash map dot. There is a method called put. Remember this. In case of uh, in case of collection class, all the members of collection class, be it list or be it sets, we were adding the values. Whereas in case of hash maps, we'll not add values, but we will put values. So there is a method called put. Now there can be a key and then there can be a value. As we have defined key as integer and value as string, so here it will take integer value and here it will take string value. Say for example, I'm putting one here and only one here. Okay, I'll copy it, put some more values, some random values. Okay, now when you have to get the value, uh, say for example, let me see if it prints with hash map. I don't remember actually whether it will print like this or not. I guess, yeah. So here you can see the values which are getting inserted here. For 1 we have 1, for 4 we have 4, 5 5, 10 10, 11 11, 12 12. Okay, so here uh, the values which you are getting, again here, I mean, key can be only one. Say for example, if I add this one again, okay, and I change it to 1, capital 1, so when you execute it, you will see that there is no, I mean, another value is not added, but the previous one is updated with a new value. So key will always be unique, whereas values can be same. So if let's say here I'm putting value as this, but keeping the value as a name as any1, let's say in small letters, you can have two things with the same name. So here you can see This is also one, this is also one. So key cannot be duplicate, whereas values can be anything. So again, as I said, employee IDs cannot be duplicate, but the name of the employees can be. So that's how values get added in the hash map. Okay, though here you can see that the order is ascending order, as my first data was as my key was integer, but in real time, I mean, actually in hash map no order is maintained. By chance we are getting an ascending order, but generally no order is maintained in case of hash map. Okay, so it's just that by chance we are getting the same order. And when we iterate over is this for loop here, here, let me just recall how we do that. Actually, I always forget this entry.
One more thing, Saurabh, like we are printing like complete hash map, all the values in all the keys. Like if we want to print a single
Yeah, yeah. Good question.
index,
Yeah, good question.
you have not told in the other one set is
Sets as
like
well.
you have
Yeah.
the
I'll explain. Just give me a second.
okay.
So in hashmap to get the values, it is like hashmap dot get, and here you need to give the key. So key here will be, let's say if you want 11, so you will put 11 in this. Okay, so let's say I want to print it, so I'll just, yeah. So to get the value, we have a method called dot get. What this will do, it will get you value of that particular key. So if I execute the code, the for 11, the value is 11. This is for hash map, and in case of sets, I'll tell in any one of the set because all the three are same. To get the value, we have hash set. Again, method is get. Uh, okay, in hash set. Okay, in hash set, what happens is we don't have any method get. Reason being because in sets we don't have any index. Okay, in lists we have index, based on that we can get the value. In hash map we have key, based on that we can get the value. Here either you will iterate over that hash map, sorry, either you will iterate over that set, or you can just verify whether that key you are looking for, whether you can get, whether that exists or not. So contains, let's say Sunday. So uh, here here in this case, uh, let me execute it again. So here you can see the result is true. Okay, getting the point why we cannot get the value in sets. The reason why we cannot get the value in set is because in set we don't have any other mapping or index associated with these things because they are randomly stored. So this Monday does not have any mapping. Tuesday does not have any mapping. Whereas in list we had index. Whereas in maps we have keys. But in sets we don't have anything. That's why we cannot get a particular value. We can just verify whether that exists or not. And in real time, generally we iterate over it. Okay, clear to all that why we cannot have any get method in sets? Okay. You can also see other methods which are available like hash set dot is empty is to check whether an hash set is empty or not. Then remove to remove any value from it. Say for example, if I remove Friday, so if I execute the code, you can see Friday is not printed from in here. Okay, so this is to remove. What else? Then we can convert a hash set into an array. This we'll discuss later. There is a scenario over this. Clear to just clear it. Add to add. Contains, I just showed you. Remove we just saw. Yeah, these are some of the methods which are available in sets. Okay, so coming back to maps, I'll just remove it. Okay, coming back to maps. We get the value using .get. Then to iterate over it, uh, there is a way, and that is, just give me a second. Let me check. Just let me give me 1 second. I'll check it because I always forget. No. Yeah, this is the syntax. Okay, so to iterate over a hash map or any map, this is the syntax. First of all, uh, here as we are using a hash map, you can either put a map or you can put a hash map, because map is an interface, whereas hash map and others are classes in it. So map dot entry, okay, this is a class which takes value in key value pair. Here we are mentioning that key is integer and value is string. Then the data type. So the data type here is temp, sorry, a temporary variable. So temporary variable here is temp colon, for over which you want to iterate over this hash map. But what? It's entry set. Entry set are these values: 1, 1, 10, 10, 5, 5, and so on. So these are the entry sets. Over this, like this, you can iterate. So here you can say, uh, let's say, I'll say key is temp dot key, get key, and then you want to get the value, so it will be value temp dot get value. Okay, now when I execute it, so here you can see key is 0, value is 1, and like this values are printed. So this is a small example how you can iterate over a maps. Clear? Any questions in this, in the maps, in hash map? So simple points to remember: map is something which stores value in key value pair. There are three types of map. One is hash map, which stores value, and then when you get the value, they can be at any random order. Though we are getting an ascending order here, not sure why. I mean, why every time we are getting this, but yeah. And keys can always be unique, whereas values can repeat, and that's how it works. Okay, any questions now in this? Okay, then moving ahead, next map we have is linked map. So I'll create a class linked hash map. We'll keep this public static void main checked, and here it will be linked hash map. Okay, okay, I guess I need to rename it. refactor, rename. Okay, linked hash map. This is what you have to take. Now here, key can be anything. Let's say this time I put key as string and value as integer. Okay, linked map equal to new linked hash map. So here it will be linked map dot add. Here when you again the methods again remain same, whether you want whether you're using linked hash map or you're using hash map or you're using the third one. Methods will remain same. Here this is, let's say, Saurabh, and let's say employee ID. Here I'm putting 98365, some value. Okay, so here some random value, and any value, Nishtha. Yeah, so or let it be this. So when we print this linked map, when we execute this code, you can see that again this time key value pair, in the key value pair values are getting stored. So Saurabh, Priyanka, Shubhanshu, Suzy, and Nishtha, all these are keys, whereas the values you see in the integer, they are the values. So you can see that values are repeating, whereas names will remain unique. Okay, and observe one more thing: the order in which you are adding Saurabh, Priyanka, Shubhanshu, Suzy, Nishtha, the same order is we are getting here. So in linked hash map, just like linked list and just like linked sets, it maintains the order in which you are adding. It maintains that. Okay, so this is about uh, linked maps. Rest everything will remain same, like iteration will remain same. So the way you iterated in hash map, same way you will iterate here. Only the variables will change. So here instead of hash map, I'll change it to linked map. Rest everything will remain same. Okay, what happened? Okay, here order is different. Okay, so now when I execute this, you can see this time key is Saurabh, value is this, key Priyanka, value this. So it will remain same. To get the value, method will remain same. It will be linked map dot get. So dot get is the method. Now in the get you can put the key. Say for example I'm putting Saurabh, so you'll get its corresponding value. So when I execute it, you'll get this value 98365. Okay, so any questions here now? Okay, so Shubhanshu, I have a question. If we use key as string, whether it is case sensitive? Yes, good question. It is case sensitive. So you need, like, if you do this, you're getting a null value. So here you can see where you're getting a null value. Why null value? Because there is no key with name Saurabh, S in small. So it is case sensitive. Okay. Any other questions? Okay, so let's look at the last one. So I'll just copy it and paste it here. We'll change it to tree map. So when I execute this code, in case of tree map, what happens is the order is alphabetic order. So ascending order. If it is a string, then it is alphabetic order. If it is an integer, then integer order, and so on. So here you can see Nishta, Priyanka, Saurabh, Subhanshu, Suzy. Like this it's coming, and again you can change the order by reversing it, and that will be collection dot reverse order. So here you can see it's now other way around: Suzy, Shubhanshu, Saurabh, Priyanka, Nishta. Okay, so this is all about maps. I mean, what we need. It's not the end. There is a lot to learn in lists, array list, linked list, maps. But for Selenium, whatever we need is more than enough. Okay, maybe at the end we can, if you'll want, we can have extra sessions to do the advanced stuff. Though it's not required for Selenium at all. But yeah, this is what we need. Main we need is iteration over lists, iteration over arrays, iteration over sets, and iteration over maps. Okay, even maps are very rarely used in Selenium. Mainly the things which are used is lists and sets. Okay, so any other questions? Okay, so let's quickly see what is left for us in Java so that we can end that up. One topic I remember is class modifiers. So that is something which is left, but that I'll take up later because I have to go through few of the concepts of that. So introduction to Java is done, environment setup done, data variables done, operators done, conditional statement done, arrays done, classes and objects done. This is done, encapsulation, inheritance, polymorphism, access modifiers. So one topic is class modifiers. So I can cover it now, but I want to go through a few of the concept here. Probably I'll discuss then. So I'll just make your parking lot and we'll cover these topics. Abstraction is done, data hiding is done, interfaces, string handling, exception handling, collection class, lists, sets, maps. So almost everything is done in Java. What we planned for, whatever is required for Selenium, only class modifiers are left. Okay, so this is something which I'll take up in the next class as the first topic. And now we can go back to Selenium. Okay, so can we go back? I mean, anything you want me to repeat in these topics? Okay, take your time. Let me know by next weekend if you want a revision of any topic. We can go through again. And I shared one book. If any one of you have started reading it, to let me know. We can have a session where we will discuss the questions from there. Okay, and then I'll start with Selenium now again. So yeah, so let's have a break for 5 minutes, 7 minutes, and then we'll start with Selenium. Okay, so see you after 7 minutes and then we'll start with Selenium topics. Okay, so let's continue with Selenium. Any questions before I move on? Okay, so the topics which we have covered till now in Selenium is, let's have a recap whatever we have covered. I mean, let's go through the topics just to see what all we have covered. So we started from here. Yeah, from day 5 we started. So we have covered one GRU 99 application. Alert handling is done. Then what else? Drag and drop mouse operations are done. And then we went back to Java. Okay, so there are few topics which are covered. So what I'm covering today in Selenium is, let me start with okay, so I'll be covering one of the topic is window handling. One is alert handling we have already seen, and frame handling we have already seen. One of the topic which was not covered in that was window handling. So let's cover window handling here. I'll keep this public static void main checked. Okay, so first of all, what we need is, first of all, we will invoke the browser, and then there is a URL. Let me show you. That is W3 schools. Okay, so there is one URL, this URL W3 schools. When you click on this tried button here, it will open up a new window or a new tab. Then if you see, automatically the control has went to the new tab. Okay, but in real time this is not the case. uh, in sorry, not in real time, in Selenium this is not the case. In Selenium the control still remains on the old window. We have to write the code to take it to the new window, do whatever you want, and then you close back and then you come back. Okay, so I'll repeat. Here I have a window where there is a button called try it. Once I click on this try it button, it opens up a new window in a new tab or a new window. This which has opened, if you see in the browser, this is the property of browser, that once you click on that right button, new window which is opened, you automatically move to that. But in Selenium this does not happen. Selenium still is referring to the old window. We have to write a code to move to the new one, then do whatever you want, then close this, then you will come back. Okay, so this is what I'm going to automate now. Any questions in the scenario? Okay, so I'll just copy invoking browser part. Rest everything will write ourselves. So I just have created an instance of Chrome driver, then defined a URL. Let me change the URL. I'll change it to this. Okay, after that we are setting a property, system.set property for Chrome browser with the Chrome driver exe. Initialize that, maximize the window, deleted all cookies, navigated to that URL. After navigating to this URL, now here we have a tried button. Okay, so if we look at this button in firepath, in HTML code, if we go to this tried button, you will see that it's a button, but it lies in one frame. Okay, so recall frame handling. What we learned in frame was, what is a frame? A frame is a page embedded in another page. So this is our main page. This HTML is our main page. In that we have embedded another page using this iframe. So first of all, you have to switch to this frame, and then only you will be able to click on this button, right? So here Here, first of all, we'll switch to that frame. So it will be driver dot switch to dot frame. Now in frame we have three ways. In frame we have three ways to switch. One is using the index, second is passing the string argument, and third one is by passing the frame as a web element. So all the three we have seen. The second one is used when an ID of a frame is given. So here if you'll see this frame iframe, it has an ID and the value of ID is iframe result. So here uh, we will pass this ID here. So now we are inside that frame. Now what I need is I want to click on this tried button. So this tried button, if you look at this HTML page, there is only one button. So here I'll simply say driver dot find element by dot tag name, and the value of tag name is button because there is only one button in that frame. And what you want to do, you want to click on it. So I'll just click on this tried button. Once I click on it, a new window opens up. So we have to switch to this new window, right? Uh, but before I switch to this new window, I should know what is my normal window, what is my parent. So let's say I call this as parent window, and the new one which is opening, I'll call it as child window. So before I click on this tried button and switch to this new window, I should know what is this older one. So this older one, we call it as parent window. So here, before we click on button, I'll create one variable and I'll call it parent window. Okay. And this parent window will be updated with one session ID, and that session ID is something which uniquely identifies this window. And we get that window by a method known as driver dot get window handle. What does this method do? This method returns a string value. And what is that string value? That string value is one session ID which identifies the window. Okay, so here this parent window is equal to a session ID which uniquely identifies this window. Any questions till now? Okay, then we switched to the frame, then we clicked on it. After that, okay, just to show you how this parent window looks like, this how this session ID looks like, I'll just print parent ID. I'll just print that. Okay, it's a string value. Now, once you clicked on it, a new window has opened. So to switch to this new window, I should know what is the session ID of that new window. Okay, then only you can switch. So for that, see what I'm doing. I'll create one variable and I'll name it child window. Okay, then this child window will be updated like this. On my browser, I'll get window. Instead of get window handle, I'm calling another method called get window handles. Look at the return type of that. This method returns a set of what? A string. So it returns us a set of what? String values. What does those string values represent? Those string value represents the window handle of all the windows which are opened by Selenium. So like early for this, I mean starting in the starting we have just this window, this single window, right? Once I click on tried button, I get two windows. So what does this method will do? This method called get window handles, it will return me two values. Those values will be the session IDs of both the windows. Okay, but as you know, just now we completed set. So as you know that sets are something which does not have an index, so we cannot get that value. So what we'll do, we'll convert that into an array. We'll convert this into an array. So I converted my set into an array. So this is an array now. And you know how can we access an array? By putting a square bracket. Whatever will be at 0 will be the first window, whatever will be at first will be the second window, right? So I got my second window. Now I'll convert that into string. I'll convert that value into string. Why I have to convert it into string? Because this method to array, this method returns an instance of object. It returns an array of object. Okay, object is something which can store any data type. So to specifically converting it into string, we'll change it to string. So now we got the child window. Any doubt in this line? Because this is very important for interview purpose. In interviews, like I have given 7 or 8 interviews of Selenium, in almost every interview, if they are taking Selenium, then this question is asked, that how will you switch to a child window? Okay, so any doubt, any questions here? If you have any doubt, any questions in this line, do let me know. I'll repeat. What I've done is I wanted session ID of the second window. So for that, what I did, first of all, I get the window head with a session ID of this. Then I clicked on this try button. As soon as I clicked, 2 windows are opened. Now there is a method called get window handles. What does this return? This returns a set of session IDs. Okay, that set consists of session ID of both the windows, this one as well as the second one. Then as you know, set does not have any index or anything to access. So what we did, we converted into an array of object. Then the value which will be of first will be stored at 0th index. The value which will be at second will be stored at first index. So I access the first index and I convert it into string. So this we are getting a session ID. Okay, just to show you, I'll just print it. I'll simply say child window ID. Okay, and then once we have got the child window ID, next we need to switch to that. So for that, it will be driver dot switch to dot window. Which window? Child window. Okay, after we switch to the child window, just to show you, I'll print the title of the page. So title of child window, uh, driver dot get title. Okay, after that, let's say I don't want to do anything else there, I'll just close it. So it will be driver dot close, and then after closing it, now once you close it, Selenium does not have anything. I mean, Selenium driver will start pointing to null. So we have to tell that come back to this window. Okay, so how will you tell? Driver dot get, sorry, driver dot switch to dot what window? Which window? Parent window. Okay, so when I clicked on it, a new window was opened. I did whatever wanted to do here. I closed it. Now Selenium is not pointing to anything. I wanted it to point to the older one, so I said driver dot switch to dot a window and pass the parent window. Then after this, I just get the title. So I'll say title of parent window, and then again, instead of close, I can call quit. Okay, so I'll just execute this. You can see. So it will execute it. Just wait for a second. It has started. Okay, where is browser? Why it is taking time? Okay, it has started. I'll just move this here. Okay. So here you can see it has opened it. Now it will click on try it button. So you can see a new tab was opened. It went to the new tab, get the title, then close that, then it went come back to the parent window, close that, and here you can see this is how a parent that session ID looks like, and this is how session ID of a child look like. And if you look at it, they are some unique random value which will never repeat, and a title of the child window, then it came back and title of the parent window. Code is very simple. First get the window handle of parent, then switch, then click on button so that you can a new window can open, then get the child window session ID. All you get driver dot get window handles, which returns as a set. Convert that into an array, access its first index, then convert it into string, then switch to that, do whatever you want, close it, come back. So to come back, we have already saved the information of parent window. We came back to parent window and then closed it. So this is how your window handling works. Very important topic for interview purpose. Any questions, any doubt in this, do let me know. Okay, so guys, one thing, I'll just stop the recording.